It's still on. Let's write really big. Lesson 47. I'm on page 308. Inscribed angles in a circle. What is something that's inscribed?
It's inside.
Written.
It's inside it.
Written
Not
inside.
like you're not scribing
From
something.
the Latin word.
Inscribed.
It's actually script.
You know, I haven't taken mine in a hot minute.
What's
Right.
the word?
I need a circle. So, can you inscribe something inside a circle?
I think so. I mean, no.
Yes. Long ago, I don't know, 6th grade, 7th grade, somewhere, you inscribed a triangle, a regular triangle inside a circle. You can do that. There's a compass involved, you do arcs, it's awesome. Or you can inscribe a hexagon, a 6-sided shape, a regular one, inside there. But if I just want an inscribed angle, where are we going?
Inside.
It's going inside
Highlighted.
the angle. Okay?
When did you start recording?
Earlier.
We have an inscribed angle that is down here. The key with an inscribed angle is the angle, the vertex, must be on the circle, and the edges must go all the way to the circle. The edges of your angle. Okay? So all these pieces have to lie on the circle. So our inscribed angle, they will say it intercepts an arc. The arc, do you remember what an arc is? It's part of the circumference of a circle. This piece from here, if we call it AB, is the intercepted arc. AB would be the intercepted arc. Okay? There's a theorem, the first theorem you wrote.
Did we already write these?
You have already written them. I assigned them to be written. I'm assuming that you did write them. No, we did it in class. Last week. No, this week on the 2-hour day.
Yeah, we did it someday.
We did it on
The 15 minutes.
the 15 minutes when we could have taken the rest of our test. That was Wednesday.
I was here Wednesday, but I didn't write.
What did you do on Wednesday? Because you guys asked me, are we going to finish taking our test? No, we did riddles.
Oh, we
We
did
did riddles,
riddles.
that's right.
Did
I was
we do it on
here,
Monday?
we did something.
We reviewed. We reviewed on Monday.
Friday.
Snow day?
No,
Like snow day.
Thursday. I think you signed these for me.
No, I remember like definitely writing them in class.
I wasn't here.
It must have been last week.
It wasn't. Wait, I wasn't here Wednesday
Was
or
it the
Thursday.
pep rally day?
It might have been the pep rally day last Friday.
Oh yeah, I wasn't here for this class. That's probably-
So if you have not written, we wrote 46 and 47 theorems. Yes, you need to do that. Okay? So theorem 47-1. Brogan, will you read theorem 47-1? Okay. What does that mean? The inscribed angle, what did it say it was?
Is equal.
It's half the measure. So the intercepted arc is, let's say it's, I don't know, 70 degrees. Arc equals the measure of arc AB. What is the measure of angle C?
35.
35 degrees.
Wait, I thought those were the same thing.
Not anymore.
If, what did I do differently? I'm glad you brought this
You
up.
took it to the opposite side.
So you have seen something where it's gone to the center of the circle and gone back out. If this is 35 degrees and this is 35 degrees, what is different?
You took it to the opposite side.
It's the vertex of the angle here is at the center of the circle. It's a central angle. This is a central angle. This is an inscribed angle. What's the difference between a central angle and an inscribed angle?
Middle.
The vertex touches the circle in an inscribed. Okay? Are we good with that? I'm 100% sure that they try to prove why it's half.
Proving and applying inscribed angle theorems.
Yes. Now, could I ask you a question? How many degrees are all the way around a circle? 360 degrees. So how many degrees are around the center of our central angle? 360 degrees. So it makes sense that they would be the same. But in inscribed, what do you know about this inscribed? What could I possibly do? We're going to pretend that's a straight line from A to B. If I have a straight line, what is A, B, C now? An inscribed triangle. How many degrees are inside a triangle? 180, which is half of 360. Okay, did we make a connection? Triangle has to be 180 degrees, where the outside is 360. Okay, but a central angle, if we added up all the central angles going around, we would still have a circle that's 360 degrees. And on the outside, the circle is 360 degrees.
Wait, if that one makes a triangle and it's half, why isn't that one half?
Because this one's not making a triangle where the angle is at. Because I can have triangles all the way around, okay? Still, their central angle will be 360. This was inscribed. Keyword, inscribed. Okay? So now, what if we start putting, they actually do a triangle. And more specifically, they cut the triangle, not the triangle. They cut the circle in half. So now GH is a diameter. Okay? GH is now a diameter. Okay, sure.
Yes.
Okay? What is the measure of angle Q?
Oh, yeah.
How do you know that, Brogan? No.
Solid guess.
It's a
Wait. What did I say GH was?
Oh,
Straight line.
Straight line.
A diameter.
Yes.
It goes through, yes, it's a straight line. It goes through the
It's half.
center of our circle.
And it's half of that.
So, what? How many degrees are half a circle?
180.
180 degrees, yes?
Yes.
Do you see an inscribed arc? What is the arc? So the inscribed angle at Q
Is 90.
must be 90 degrees. Are you okay with that? If a diameter, if it's cut into a semicircle, I think that's what the theorem says. Gray, will you read theorem 47-2?
I would love to.
Gray, read, please. I don't think we all heard you.
If an inscribed angle intercepts a semicircle, then it is a right angle.
So does everybody see the semicircle? Semicircle, whatever you say. Yeah. Is it okay? It has to, we will prove it somewhere that that will be a right angle. What about something thing. Let me draw another circle. Lots and lots of circles. And I'm tired of purple. M, N, O. And P is in the middle, it's the center. And then we go this way. And then we go this way. M, O, they all touch the edges. And I tell you that this side over here is 64 degrees. Several questions for this circle on the right side. What is the inscribed angle? What? Okay, let's
Oh,
turn it all up. Let's turn it all off. Just a second.
I have a question that's not the answer.
What is your question?
Is that an O or a D?
It's an O. I don't use O's usually. The book did.
Just use James.
I need a paper towel.
Okay, this is kind of obvious.
Oh. My bad.
Does everybody have in your head what is the inscribed angle? In your head.
Could there be more than one?
Well, you could say it two different ways, but there really is only one. Do you have it? I hope so too. Mallory, can you tell me what is the inscribed angle? MPO. P is at the
Center.
center. That is a central angle.
That's good.
Now I know.
Inscribed angle is what?
Oh.
You were just gonna say O?
Well, M-O-P.
N to O to P.
No.
No.
N-O-M. N-O-M.
You cannot just tell me angle N either.
Oh,
Because angle N goes lots of
Oh,
different
M-N-O.
M.
Gray was
Gray's right.
Or you could say O-N-M. But it has to go
all the way.
all the way, and each endpoint must be on the circle. That's why you couldn't stop at P. Couldn't be O-N-P. Had to go all the way to
On.
Okay. What is the intercepted arc? What is the intercepted arc?
Good question. Oh. I know.
They already have it. Jacob, what is the intercepted arc?
M-O?
Is it arc M-O?
Yes.
It's
It's
O-M.
M-O.
O-M or M-O? Yes.
Here.
M-O.
If the angle MPO is 64 degrees, can you find the measure of angle MNO?
Yes.
What? Stop. Stop. Everybody's going to find it. What is the measure of angle MNO? I'm not ever going to give you something that's impossible.
Impossible. Get it?
Do you have it? Wayne, what is the measure of MNO? No, just the angle. Just one angle that's all the way over here.
right.
is
That is
64?
true. Mo.
What else is 64? That you
Intercept.
automatically know.
The intercepted arc.
Oh yeah.
Well, you know
Mo.
angle P is 64 degrees, but what else is 64 degrees?
Mo.
Which means.
Wait, I would.
Because-
Mo would be double that.
No.
No, central angle, intercepted arc is the same, but inscribed angle is going to be what? That's when we start halving and doubling. Okay, so if you know the arc, MO, is 64, what is the inscribed angle? 32 degrees. So you do have to remember that a central angle, its intercepted arc is the same, but sometimes we're going to have to half it to get the small one. What is the measure of NO, the arc NO? Shh. What is the measure of arc NO? Keep it. I will call on somebody. What is the measure of arc NO? You think you've got it. The question is, does John have it? And does Jacob have it? And does Morgan have it? Mallory has it. Brogan, what did you get?
116 degrees.
How did you get that?
Well, it just makes sense.
What makes sense? How does it make sense?
It all just comes together in 116.
How did you get that? How did you get just pull that out?
Well, because
Sure.
it's
What?
like 180 degrees.
Oh. Okay, so this being a diameter, this whole thing has to be 180, and you know 64. So you did 180 minus 64.
I reckon.
Yes?
Alright.
I reckon. Alright,
I suppose.
I suppose. Theorem 47.3,
Hold up, there's another one.
there's two more.
Would you
Oh,
like me to read?
I would love for you to read it, and then we'll pretend I can draw it.
If two described angles intercept the same arc,
That's wrong.
they are
It makes something crazy like this. Okay?
Whoa.
Whoa.
Hold up.
Now, if I start putting letters, A, B, C, D,
J.
okay? And I give you one thing. I give you the measure of angle C is, let's say, 25 degrees. No, that's very off, but maybe we'll switch and do 52. That maybe looks more like a 52 degree. Maybe? We'll pretend.
Say 90 degrees.
It's not 90. We're not going to do. Nothing is cut in the semicircle. Okay? Nothing is 90 degrees.
Well, besides,
Nothing. Could you tell me?
since you have a midpoint in between.
No midpoint. Could you find the measure of angle B? If I need to use three letters, I really don't.
If you really wanted
A.
to.
Theorem 47.3.
I don't really. What do you mean two inscribed angles? Where's the arc that they understand?
Well, I'd like for you to see. Do you see?
it.
Do you see angle C? What
Yeah.
arc does
It
angle
is
C?
AD.
Do you ever see? I'm gonna go over the rest. your intercepted arc is AD.
And guess what?
Yes?
It just happens to be the same with B.
Now, I'm gonna go and do.
Oh, okay.
Why are we doing
Be like,
this? Is how the Lord wants to
Angle B. What is angle B's intercepted arc?
AD.
it does
AD.
be like that sometimes.
It do be like that.
Okay. I make assumptions that you're a little bit more mature, okay, than my second grader, who's like, why do I do this? Am I ever going to need this? You go to school to learn a process of learning. I don't expect you to know and use everything you find and do in classes. So
Do
you're
you know and
never
use
gonna
everything
need-
you do in classes?
Do what?
I said, do you know and use everything you do learn in classes?
No.
She hasn't written the paper.
That's just proof of your point.
Or, well, I don't know if you have enough, but you did say that you just have
I'm not a good paper writer, but I didn't have to write papers in school.
What?
Why not?
Because I went to a horrible school.
Because
I
I
went
went
to
to-
college.
But it prepared you
Wait,
to be
where
did you go to college?
I went to MTSU.
Did they make you write papers?
Probably.
But it
Prepared
prepared
you to be a good
But-
math teacher.
Okay, well, I'm not going to say this being recorded, so we can wait till after I stop.
Oh!
God, everybody that's listening
So,
to the recording is
what?
gonna be
What is the measure of angle ABD?
Ugh.
What is
32 degrees.
52
Maybe
degrees.
it's
I
already
reckon
37 degrees.
Okay, stop. If we need to find out if the measure of ACD is 52, what's the measure of arc AD?
100.
John, what is it? 104 degrees. Okay? You could go along and do that. So ACD is 52, so its intercepted arc is double that. So the intercepted arc is 104. Again, the intercepted arc is 104. Its inscribed angle is now B. It's also B. So the arc is 104. What's the inscribed angle?
52.
Half of that, which is 52. So if any inscribed angle has the exact same intercepted arc, the angles must be congruent. That's what 47.3 says. So when you read it, it doesn't make sense until maybe you see it. You don't see the two angles, the inscribed angles, in the same arc.
I don't understand how they add up. How you
They-
know they add up and equal. Well, like, how that angle right there equals.
AB. Because it's double the ACB. Because ACB.
But why is it? Why is it?
Because it's an inscribed angle. It's always half the angle it goes into, or whatever.
I think Brogan here wants a proof.
No.
Wow.
I don't know.
Why?
We suddenly got it. It's okay.
He
Yeah, I
suddenly.
understand.
I think it may be time.
No.
I was just joking.
What was that little thing that you can't see on the recording?
We're going on. If a quadrilateral. What is a quadrilateral?
It's recorded, it can be held.
It's shaped with four sides.
A shape with four sides. If a quadrilateral is inscribed, oh, I'm going too many.
That's a
1, 2,
pentagon.
3, 4, yeah.
That's a pentagon.
It's supposed to look like
That
a
right there beats
triangle.
pentagon.
It doesn't matter as long as it's a four-sided shape.
Wait, so that's 360.
So inside
Then it has
Inside. a quadrilateral is how many degrees?
360.
360 degrees. So let's put some letters up here.
Oh. And it's
A,
opposite
B,
angles are
C,
supplementary.
D.
J.
Now, what about arc? Let's say inscribed angle B.
Wait, Miss Evans,
Inscribed angle B has what arc?
AC.
AC.
Before we get started,
No,
telling me-
we're moving on. We're not stopping. I don't like that arc. So we have AC, okay, as an arc.
It looks better when you go up very much.
What about angle D? Inscribed angle D. Did you say those are opposite angles, B and D?
They're supplementary.
Okay, what is that inscribed angle?
AC.
Well,
see the other way around.
so if I want to say
ABC.
An
It's
arc.
major arc. It's a
it's
major
a major arc ABC, so here's my major arc. But what has happened? Minor arc AC and major arc AC, what do they add up to? It's a circle that's 360.
A circle. Don't say.
So inscribed angle D
Is
plus
supplementary.
inscribed angle B.
180 degrees.
So we did two different ones. The theorem says these two will be supplementary.
Okay, that color combination looks really good.
Opposite angles
You're
will
welcome,
be
Lydia.
supplementary.
You're
There
welcome,
could be
Lydia.
more than one inscribed angle.
Yes. In this one we did two. Like this one, we did two inscribed angles. Right now, there are four.
You can do as many as you want.
As many as you can technically fit in there.
I reckon.
Okay? Inscribed angles, if it's a quadrilateral, the opposite angles will be supplementary. Only if it's a quadrilateral. Nope. It will not. So angle A plus angle C. Angle A plus angle C has to equal what?
180 degrees.
180 degrees. Angle B plus angle D has to equal
180 degrees.
180 degrees. Now, nothing says that they have to be, one could be 100 degrees, the other could be 80. We could have 90 and 90. We could have any combination, 170 and 10. Okay? As long as, but they will always be supplementary. Okay? So when they give you an angle is 4Z, angle A is 4Z, and angle C is 3Z plus 5. Did you get that? Angle A was 4Z. Angle C was 3Z plus 5. What is the measure of angle A? What's the measure of angle C?
You gotta combine them so
Okay.
you get 180
I need everybody to solve. Yes, you can. You're going to. We've talked about being positive and nice before. Positive, encouraging, uplifting.
Wait, we're supposed to find Z. Is that what you're saying?
Well, the ultimate goal is to find what is the measure of angle A. But do you have to find Z first?
Yeah, no.
You
I
can't
got
do it without it.
Wait. Oh, you have to add them together.
All right, then thank you for volunteering, Greg. Come up to the board.
Oh no.
Come up to the board.
I can't
And
draw. on the
work
board.
this out.
I can't draw.
I'm giving you permission right now.
Well,
It's
I
fine.
really don't think I should.
I really think you should. Today is definitely
Not
The
the
not
day.
the day. It's the day, Greg.
I
Today's the
got
day.
it. I'll just do it right here.
No.
Yeah.
So you're volunteering Brogan. Greg and
No,
Brogan, come on up.
No.
Come on up.
No. Great.
Yep.
Throw your friend under the bus.
I think Eli should.
Nope. Eli's not in the picture right now. Gray and Brogan
And
are the
John.
ones not writing anything down.
I'm
no piece of
mental
paper.
mathing.
I lost
Standing
my
up.
paper. I had it right here, Miss Evans.
You're standing up and you're
I
coming
had
to the
it here.
board.
I had it.
Mental mathing.
You okay?
That's a good.
You know what? It's no day this week, so we've not had homework a single day this week.
No, I meant to.
We should keep that streak going.
I got it.
That sounds
Okay,
like
I'll work on
your
that.
It's been a rough week.
It has been a rough one. Is this it? Will you?
Where do you
I don't know.
start?
It's been about the easiest week you had.
It's just been
This is that.
La
I don't know.
distancia desde siempre.
Yeah.
Ha.
Fifth grade teacher.
well.
A pyramid in Spanish.
I'm excited because
Cuadrito,
we're in it.
formado por una
Okay, let's stop, please. If you are not being helpful in a math conversation, don't talk.
God, it was wow.
Now you can do it on the board.
I got it.
You got it? Wow. Elon, please stop. Or more. Until Gray or Brogan decides to come to the board and work it out for us.
Wait. We'll be in there until then?
Until,
Oh.
for sure, at least until then.
Take it
I
away, Greg.
guess.
Alright, yay!
Alright.
I think I got it.
What are you doing?
We can both do it and then compare answers.
And then afterwards, you can stop the recording and tell us what you're going to tell us.
I'm doing it as small as I can. So.
Thank you, Brayden.
Oh, I gotta go get my paper again to see if I can.
Are you going to tell us what you can't tell us on recording the sevens?
Well, it's still on recording.
That's what I got. When I get back to you. Whoops, I messed up.
It smells like nothing.
It depends if you like the smell of leather. Some people don't.
I don't love these videos.
All done.
Ain't that something? Now that I've been wearing it, it's not as boxy.
I did it just that way.
Yes.
Still too long. But I'm just short.
Yay.
I mostly like those answers, but there's some people I don't like about them.
Agreed.
Yes, if you're this short, I mean, they're probably like that much longer.
Gray, out of 4 degrees up here, Gray's the only one that put one of them somewhere.
I'll go back.
Your answer
Put it on one.
needs degree.
Whoa.
Wow. So much
I
like this on the board.
And
Lydia is going to love this.
What are you talking about? That's totally.
Yep.
Are you making fun of that?
Are you making fun of my handwriting?
There we go.
Alright, so you have set them all equal. We can find those missing pieces.
That's a huge trick.
And then we can stop.